Okay, this is the first example from 6.2, which is trigonometric equations. So we're actually going to be using all of the stuff that we learned about the trig identities and just algebra to solve equations that involve trig functions. So before we do that, I wanted to make sure that we go over one thing about them. So here's a sine wave. And remember that if it's a normal sine wave, that it ends in a period of 2 pi. Pretend that's perfect. But notice in the period of 2 pi, it crosses the x-axis here and here, which means, remember, anywhere something crosses the x-axis, that would be considered a solution. So whenever we're solving sine equations or cosine, so we could do a cosine wave. Let me switch colors so you can see the cosine wave. So if we were doing a cosine wave, it would go like, well, pretend. Yeah, it's terrible. You know what I mean? Anyway, a cosine wave is also going to cross in 2 places. So there's going to be 2 solutions, but we also know that these things go on and on and on forever, which is why they'll give you an interval over which you are finding the solutions so that you're not having to write down infinite solutions. So that's why they're giving you that interval. And then you'll see here B for all solutions, but we're going to generalize a way that we can write down the answer for all solutions. So you don't have to just keep listing and listing and listing, because you couldn't do it all because it's infinite. All right, so if we are solving this for 2 sine theta plus 1 equals 0. So the solving part of it is going to be pretty much just algebra. The goal here is to get theta by itself, to find out what theta is. And theta is an angle, remember. So I'm going to, just like all equations that you've done in the past, get rid of what's most loosely attached, and addition is much looser than multiplication. So first thing I'm going to do is subtract 1, and that leaves me with 2 sine theta equals -1, and then, excuse me as my brain gets ahead of me, and then you are going to divide by 2. All right, so now I have sine of theta equals -1/2. So this is where I need to get theta by itself. To get theta by itself, you have to do the opposite of sine, which should be, or the inverse of sine, which would be arcsine. So I'm going to take arcsine of -1/2. Now, of course, you can put that in your calculator, but if I put it in my calculator, I'm going to get decimal answers, and I want, for a half, that's on the unit circle, I probably want exact answers. So I just have to ask myself, where is sine -1/2? So first I can remember that all students take calculus. This is where sine, these are where things are positive. So sine is positive in 1 and 2. So that means my answers are going to be in 3 and 4, because that's where sine is going to be negative. Then I just ask myself, okay, well, where is sine 1/2? You can use the left hand trick if you want to do that. Sine is the y value, so it's going to be on bottom. I need 1 finger. So that means I would fold in that first finger, which means at 30 degrees. So right here, y would be 1/2, which means it's also going to be 1/2 right here. Now they ask me, so yes, that's -30, but they asked me to find it on the interval of 0 to 360. So if I was going 0 to 360, then that right there is 330. So that's one of the answers. And the other place would be right here, and that's 30 degrees away from 180. So that means it is also at 210 degrees, because 180 plus 30 is 210. So those are my 2 answers. Remember, we said in a period of 2 pi, or 1 trip around the unit circle, in the period of 360, sine would have 2 answers. And there's my 2 answers. Now, when it says for all solutions, that means after the 210 and after the 330, if I were to start going around the unit circle again. So let's say I made my trip around, I got an answer here, and then I get an answer here, and then I decide to go around again. I'll get another answer here and another answer here, and then I go around again. And you would get answer after answer after answer. Well, that means what you're doing is you found your theta, which was 210. I'm going to put the smaller one first. And then I'm going to take a trip around the unit circle, 360 degrees. as many times as I want, 360 times n. That's the number of times. That's one of my answers. And then I'm going to have a 330 plus 360 n. That's the generalized answer for all solutions.